At 4 p.m., Adam is 100 kilometers north of Bob. So at 4 p.m., Adam is 100 kilometers north of Bob. So say this is their approximate location. Oh, that's not Bob, it's Bob. Okay, so Adam is biking south at 24 kilometers per hour, so he's going south, and Bob is biking west. Bob is going this way. So let's give some names. Let's say the distance covered by Adam is A, so that's how he travels. And by the way, this distance A to B is 100 kilometers. And let's say Bob goes B units. And let's see, we're given the derivative of A with respect to time, velocity of Adam, that's 24 kilometers per hour. And Bob's velocity is 10 kilometers per hour. Okay, and we're looking for the distance between these people at 7 p.m. Say after some time, Adam come here, Bob came here. The distance between them will be this line. And let's call that distance as, oops, that's not very nice length. There you go. Let's call that distance as c. So we're looking for how fast the distance between these two people is changing. So we're looking for dc over dt. And when are we looking at this, by the way? We're looking at this at 7 p.m. So we started at 4 p.m. We're looking for the rate of change at 7 p.m. The time passed is 3 hours. Right? And I can see that in 3 hours, Adam traveled 3 times 24, which is 72. Bob traveled 3 times 10, and he traveled 30 kilometers. And we need to find C probably. We can use the Pythagorean theorem. We have to be a little careful because this is a little different. Adam is biking towards the intersection, not away from intersection. So our triangle will have the sides B and then 100 minus A for this portion here. Because the total was 100 here and Adam traveled A units, then the remaining part will be 100 minus A. So our triangle has sides B, C, and 100 minus A. Using the Pythagorean theorem, I can write 100 minus A squared plus B squared equals B squared equals C squared. And let's go ahead and find C, and then we can come back here and find the derivative and finish up the problem. So this is our equation. 100 minus A, 72, squared, plus B squared, that is 30. B is going away from the intersection, so we don't have to subtract it from anything. Then that's equals to C squared. If we do this computation, we should get C squared equals to, let me see, C squared equals to 1684, then approximately C will be 41.03657. Okay, and now we're going to find the derivative, and then we can use all the information we know to find the rate of change in C. So derivative of the left side will bring 2 down times 100 minus A to the power 1, I don't have to write it, times derivative of negative A. That will be negative dA over dt. Derivative of 100 is 0, so I don't have to write it. Plus, derivative of b squared is 2b times dB over dt equals derivative of c squared is 2c times dc over dt. To simplify it a little bit again, we can divide everything by 2 so that we get rid of that extra number. So we have 100 minus a times, let's put that negative sign in front here, times dA over dt plus b times dB over dt equals c times dc over dt. And we're just going to plug in the information we have. Negative 100 minus a, that's 72, times dA over dt is 24, plus b, that is 30, times dB over dt is 10, equals c, I'm running out of space here, 41.03, let's say 04 after I round off, times dc over dt. And left hand side should give us negative 372 equals, now I'm just going to write the full length since I have space, 03657 dc over dt, and then divide by this number. So we get dc over dt is approximately negative 19.287 kilometers per hour. So meaning of negative is that the bikers are actually getting closer. This distance between them is shorter. And it's kind of expected because Adam is biking towards the intersection and his speed is a lot faster than Bob's speed.